polarized components. So that was just for reference again. Yes, yes. Okay. So, in ordinary magnetic fields, we can observe the nuclear Zeeman effect as the state I splits into its components, right. So, in ordinary magnetic fields, for example, we can observe the nuclear Zeeman effect as the state I splits up into its 2I plus 1 individual substates. So, we can say that M is equal to minus I plus 1, so on I minus 1 and I. So, this is again similar to the quantization concept, right. So, these substates are equally spaced and is in the atomic normal Zeeman effect. So, the Zeeman effect we talked about previously was for the atomic Zeeman effect, but now we are talking about the nuclear part of it. So, if we could apply an incredibly strong magnetic field, so strong that the coupling between the nucleons were broken, we could see each individual J splitting into 2J plus 1. So, first we saw it on a bigger scale, and now if we apply the same concept, we can see of course, we will have to design an experiment with a strong magnetic field and so on. Then we can see that it will each nucleon will also experience the same effect. Then each individual J splitting into 2J plus 1 substates. So, we are always, what we are doing is we are always using the concepts that we already understand about electrons and the atom, and we are now applying them to the nucleus, and we do know that this is a resultant of the nucleons. So, we first talked about the Zeeman effect in the atom, then we talked about the nucleus as a whole with capital I, and then we said that actually this same phenomena can happen in the case of each individual nucleon, and therefore, J itself can split into its components provided you create the right conditions. Okay, कहाँ तक लिख यहाँ तक थी? Okay. Okay. But it is difficult to produce such a magnetic field that can actually show us. Huh? क्या? At the moment it's just treated as a number, okay. We are just talking of it as a number, right. Okay, so but it's difficult to produce this kind of a field where you can actually decouple them and you can measure them. So what we do observe is the on the whole effect of the nucleus, which is capital I. So it's difficult to observe J itself. So the nucleus itself in most experiments and in most applications behaves itself as a single particle or as a single entity. But you wanted to go further into that. Even protons and neutrons, we look at their combined effect when we are looking at the nucleus. Okay. So for this reason, the spin total angular momentum I and the corresponding spin quantum number I are used to describe the nuclear states. So since it is difficult to observe the individual nucleons and their J values and so on, we observe the nucleus as a single entity. So the nucleus behaves as a single spinning particle, and therefore for this reason the spin, which we are also calling the total angular momentum, capital I, and the corresponding spin quantum number are used to describe the nuclear states. Okay. Now let us clarify that I from now on will denote nuclear spin and J represents the total angular momentum of a single nucleon. So this is for one nucleon and this is for the nucleus. Now, it can be a case that all the nucleons do not contribute to the spin of the nucleus like we discussed last time. It's possible that only, let us say, maybe one single valence nucleon determines the nuclear properties of a nucleus. है ना, ये बात की थी ना हमने last time when we were talking about the concept of pairs and all that. So we did say that it's possible that पहली बात हमने की थी कि a nucleon is not influenced by all the nucleons, it may only be influenced by its neighbors. लेकिन the nucleons at the surface play a particular role because unke neighbors are different than those in the core of the nucleus, they behave differently. The second thing is the nucleons on the surface can also behave like a valence nucleon. The same concept that you have for electrons, hai na? Electrons may, it's one single electron that may be in an outer shell that plays an important part in changing the properties of the overall atom. In this case, it's also possible that one single nucleon behaves as a valence nucleons, and this is responsible for the overall properties of the nucleus. And therefore, in that case, it is possible